Alright, today we're looking at kind of a mix of 7.4 and 7.5, part 2 of solving equations, just a little bit more difficult problems for that. So now we're going to actually be using our properties that we learned to kind of combine them together and do some solving with that. So here you can see we have subtraction, and we have the same base. So if we're going to write this as a single log, I would say log base 3 of x over 4 equals 2. Now at this point I can switch this into an exponential function. So remember the base stays the same, so the 3 goes here, and then the 2 and the x minus 4 are going to switch sides, or not x minus 4, sorry, x divided by 4. So this would become 9 equals x over 4, and then you would multiply both sides by 4, and you would get x equals 36. Okay, similar situation going on here, so we're going to condense it into one log first. I have the same base here, and I have addition, so that means I'm going to combine them through multiplication. So log base 6, so if I'm multiplying an x times an x minus 9, that's going to become x squared minus 9x equals 2. Now we will put this into an exponential function. So the base, identify the base first. The 2 is going to come over here as the exponent, and all this stuff is going to go here. So now this is equal to 36. And now I have a quadratic. So to solve a quadratic, I need to bring this over to the other side. Okay, now we need numbers that when I multiply them, I get 36, and when I add them, I get negative 9. Oh, sorry, this would become a negative 36. I don't want to make that mistake. So this would be minus 12 and plus 3. And then that would give me x equals 12 and x equals negative 3. But when you're solving these, negatives are not in the domain of log functions because of the fact that if I take like 6 to any power, I'm not going to get a negative number out. That's not possible. So I'm going to cross that one off. That one would be an extraneous solution, and the x equals 12 is my only actual solution there. Okay. On this next one we have natural logs. So remember the natural log is base e. So even though it's not written on there, it's automatically a base e. So since I have addition, I'm going to combine these into one with multiplication. So this would be natural log of 2x equals 3. So now I have a base e here, so I'm going to say e to the third power equals 2x. And then this stuff can get typed into the calculator. So the e is going to be right here. So I'm going to hit second to get that. And to the third power. And then I would, if I was going to get x by itself, I'd be dividing both sides by 2. So to get a more exact answer, I'm going to type that all in at once. So divide by 2. And I get about 10.04. So I'm going to make this an approximate symbol. Okay, so example 4. So I'm going to take this side here and I'm going to combine those into one using my properties of logs. So since it's addition, I'm going to multiply those. That's going to become 81. Over here I can use this our power property, and I can make this an exponent. So this is log base 7 of x squared. So now at this point I have two logs that are the same. So we have the same base, so those can just drop off. I have x squared equals 81, which means x equals positive and negative 9. But since the negatives are not in the domain of log functions, we're going to have x equals 9 as our only solution there. Okay, two more to look at here. So example 5, we have an e again. So again, this is going to be a situation where we're going to use a natural log. But I want to get this e kind of by itself. You want to simplify the exponential function as far as you can first before you can switch it. So I would first subtract 5 from both sides. Now I can divide this 2 off on both sides. So I have e to the 2x plus 1 equals 55. Now this is a point where I can switch this into a log function. It's an exponential. I'm going to switch it into a log. So it's going to be natural log. The base is e. You can write that or you don't have to. It's implied that it's base e. The 55 would come over here. And the 2x plus 1 would come here. Now this is just something that we type into the calculator. So on here, I would use my natural log button, which is automatically base e, and put 55. Now if I look at what I would be doing to solve this, let's look back here. I would be subtracting 1 and then dividing by 2. So if I do that all at once on the calculator to get a more accurate answer, I'm subtracting 1. I should have parentheses around this, so I'm going to do that. Well, let's just do this. And then divided by 2. We're at about 1.5 for that. So this, I would say, x is about 1.5. Okay, last one. So here, again, we don't have a base written, so that means this is a common log on this one. But I do have addition, so I can simplify it using multiplication. So this would become x squared minus 3x. Okay, now I can switch this into an exponential, so I have 10 to the first power equals x squared minus 3x. So this is just 10, so I'm going to bring that over to the other side. And then can we factor that? Minus 5 and plus 2, which means x equals 5, x equals negative 2. So that one's not actually going to work. That's going to be extraneous, so that's going to be our only solution here. Okay, so at this point, this is what you're looking at for the two of them to try on your own. And for your joke, why couldn't the shoes go out to play? It's because they were all tied up. Okay, I hope you have a great rest of your day and make sure you're kind to someone today.